Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about cross correlation function of the random process x of t and y of t and um, verify jointly WSS or not. The example is two random processes are defined as x of t is equal a cos of omega t plus theta and y of t is equal b sin of omega t plus theta, where theta is an uniform random variable on 0 comma 2 pi and capital A and capital B, capital A comma capital B and omega are constants. First bit, find the cross correlation function, and second bit, verify whether x of t and y of t are jointly WSS or not. Coming to the solution, given that the two random processes are x of t is equal a cos of omega t plus theta and y of t is equal b sin of omega t plus theta. So now here capital A, capital B and omega are the constants and theta is a uniform random variable over the interval 0 to 2 pi. So therefore the uniform probability density function of the random variable theta is f of theta is equal to 1 by 2 pi over 0 to 2 pi. First bit solution. We know that the cross correlation function of the random process x of t and y of t is rxy of t comma t plus tau is equal expectation of x of t y of t plus tau. So given that x of t is a cos of omega t plus theta and y of t is a b sin of omega t plus theta. So therefore rxy of tau or rxy of t comma t plus tau is equal expectation of x of t is a cos of omega t plus theta. So given that y of t is there and y of t plus tau value is b into sin of omega t plus omega tau plus theta. AB is constant, that is written before integration. So this within the bracket term is the 2 sin A cos B. So now here 2 is missing. So multiply numerator and denominator by 2. So we get AB by 2 into expectation of this within the bracket term is 2 sin A cos B sin of A plus B plus sin of A minus B. So directly I am writing here expectation of sin of A plus B. Omega t plus theta is the A, omega t plus omega tau plus theta is the B. So sin of omega t plus omega tau plus theta plus omega t plus theta. So this is the A and this is the B plus sin of omega t plus omega tau plus theta minus omega t minus theta, so which is equal AB by 2 into expectation of sin of 2 omega t plus omega tau plus 2 theta plus sin of omega tau. So now applying the expectation into each term, Rxy of tau is equal AB by 2 into expectation of sin of 2 omega t plus omega tau plus 2 theta plus AB by 2 into expectation of sin of omega tau. So using expectation of x of t expression, expectation of this function is integral 0 to 2 pi this function sin of 2 omega t plus omega tau plus 2 theta into density function of the theta, that is 1 by 2 pi into d theta plus AB by 2 into expectation of this function is using expectation of x of t expression integral 0 to 2 pi sin of omega tau into density function of the theta is 1 by 2 pi into d theta. From the given data, the range of the theta is 0 to 2 pi. So 1 by 2, now we are integrating with respect to theta. 1 by 2 pi is constant, that is written before integration, which is equal AB by 2 into 1 by 2 pi integral 0 to 2 pi sin of 2 omega t plus omega tau plus 2 theta d theta plus now we are integrating with respect to theta sin of omega tau by 2 pi is constant, that is written before integration into integral 0 to 2 pi 1 d theta. So integral 1 d theta is theta over 0 to 2 pi. So integral sin of 2 omega t omega tau plus 2 theta integration is with respect to theta cos of 2 omega t plus omega tau plus 2 theta by 2. So integral of sin of this term is minus cos of 2 omega t plus omega tau plus 2 theta by 2 over 0 to 2 pi. And integral of 1 d theta is theta over 0 to 2 pi. So now here substitute upper value of theta and lower value of theta. Here also substitute upper value of theta and lower value of theta. We have minus ab by 8 pi. So now here directly I am writing, after substituting upper value of theta and lower value of theta in the first term of the first term, cos of 2 omega t plus omega tau plus 4 pi. Cos of 4 pi plus 2 omega t plus omega tau is cos of 2 omega t plus omega tau, minus second term is substitute the lower value of theta, that is theta is equal to 0. The first term of the in the first term, substituting the lower value of theta is equal to 0 value is cos of 2 omega t plus omega tau. So now here one is the plus term and another one is the negative term. So these two terms are the cancel. This within the bracket term is 0 plus ab by 2 into sine of omega tau by 2 pi. And the second term substitute upper value of theta and lower value of theta. 2 pi minus 0 is 2 pi. So now here 2 pi is the cancel. And the first term is 0 and the second term is ab by 2 into sine of omega tau. So now here the cross correlation function of the random process x of t and y of t depends on tau. Hence the given random process x of t is a x of t and y of t are stationary random process. And the second bit solution, the condition for two processes to be jointly WSS is expectation of x of t is constant and expectation of y of t is constant, and cross correlation function is independent of time. If this condition is satisfied, given two random processes x of t and y of t are said to be jointly Whiteson stationary process. So now here in the first bit Rxy of tau is already calculated, that Rxy of tau expression is independent of time t. Hence the random process x of t and y of t are Whiteson jointly Whiteson stationary random process. So now calculate expectation of x of t value and expectation of y of t value. First calculate expectation of x of t. So expectation of x of t. So now here x of t is given that a cos of omega t plus theta. Now here theta is the uniform random variable, a is constant, that is written before expectation, which is equal a cos of omega t plus theta. So using expectation of x of t expression, expectation of cos of omega t plus theta is integral 0 to 2 pi. Now where the function is cos of omega t plus theta into density function of the random variable theta is 1 by 2 pi into d theta. 1 by 2 pi is constant, that is written before integration. Integral cos of omega t plus theta is sine of omega t plus theta over 0 to 2 pi. So now substitute upper value of theta and lower value of the theta. We have a by 2 pi into sine of omega t plus 2 pi minus sine of omega t plus 0. Sine of 2 pi plus omega t, sine omega t minus sine omega t. So plus sine omega t minus sine omega t is cancelled. This within the bracket term is 0. A by 2 pi into 0 is 0. So expectation of x of t is 0. So now here the condition is satisfied. Next, similarly calculate expectation of y of t, given that y of t is b sine of omega t plus theta. Now here theta is the random variable, b is the constant. So b is written before expectation, which is equal b into expectation of sine of omega t plus theta. So using expectation of x of t expression, this expectation of sine of omega t plus theta is integral 0 to 2 pi sine of omega t plus theta into 1 by 2 pi d theta. Integral sine of omega t plus theta is minus cos of omega t plus theta over 0 to 2 pi, so which is equal to minus is written before minus b by 2 pi. So now substitute upper value of theta and lower value of theta. We have cos of omega t plus 2 pi minus cos of omega t plus 0. Cos of 2 pi plus omega t, cos omega t. So plus cos omega t minus cos omega t is cancelled. So therefore the RHS term is 0. So expectation of y of t is equal to 0. Here also the condition is satisfied. Hence The given random process x of t and y of t are said to be jointly Weights and stationary random process.